Hello everyone. In this video we're going to learn how to apply the integral reduction formulas for sine, cosine and tangent. I have already pasted the formulas on the board, some useful identities that we're going to use, and derivative and antiderivative rules for sine, cosine and other trig functions. Let's work on the example of sine 4 of x. Integral reduction formula for sine is -1 over n cosine x sine n minus 1 x plus n minus 1 over n, again integral of sine n minus 2x dx. Here, since we are integrating sine, be careful that n minus 1, n minus 2 is on sine. And here, our n is the power of sine. So our n is here 4. So our integral turns into -1 over n, which is 4, cosine x sine x, and sine has the power n minus 1, which is 4 minus 1 is 3, and plus n minus 1 over n, 4 minus 1 over 4 is 3/4, and again integral of sine of 4 minus 2, which is 2 x dx. So this part of integral is done. Now we need to integrate here. Here you can apply integral reduction formula again, or you can apply half angle identity. So whichever you want, you're still gonna be getting the same answer, because at the end of the integral reduction formula, you're gonna apply some identity and make it compact. So let's apply both then. So here, let's use integral reduction again. And here, let's use the half angle identity. So by the half angle identity, sine squared of x is equal to this. Sine squared of theta is 1 minus cosine 2 theta over 2. If you pull out 1/2 to the out, you get 1 minus cosine of 2x. So we're going to substitute 1/2 times 1 minus cosine of 2x instead of sine squared of x by the half angle identity. For integral reduction, we're gonna use again the same formula. So let's set that up. It's going to be, this time our n will be 2, because sine squared of x, that's what we are integrating. So it's going to be 1 over n, which is 2, cosine x sine 2 minus 1 is 1, which is sine x, plus n minus 1 over n, 2 minus 1 is 1, 1 over 2 is 1/2, and integral of sine 2 minus 2 is 0, x dx. Anything to the 0th power is 1, so here we are technically integrating 1 dx. And what we get here is -1/2. Here, cosine x times sine x by the double angle identity is equal to 1/2 sine of 2x. If you apply the double angle identity, you can make it more compact. And plus 1/2 times antiderivative of 1 with respect to x is x, and 1/2 times x is 1/2 x, and plus c. So this is what we get if we apply the integral reduction again at this part of the integral. If we apply half angle identity, then our integral turns into 1 minus cosine of 2x dx. So 1/2 times antiderivative of 1 with respect to x is x. We have negative sign here, and cosine of 2x turns into 1/2 sine of 2x plus c. And if you compare these two integrals, they are exactly the same. So our final answer for sine fourth of x will be this block, which is negative 1/4 cosine x sine cube of x plus 3/4 times one of these blocks, because this is coming from sine squared of x. Let's pick up this one. So this is our final answer. You can apply integral reduction formula for cosine and tangent using these formulas. Try cosine and tangent by yourself and write your comments below, please. Thank you for watching.